I think I put in the wrong numbers, but it doesn't matter. I mean, as of yesterday, these are one, seven, come on. As of yesterday, 1 year rate was 361, but we have other rates too. I mean, as an example, I put in the rates at the beginning of the year. These are the actual ones. So I'm going to make this green. I'm also calculating the log of these. There's a reason for that. I'm going to come back to that. And for each of these maturities from 1 to 30 years, first I get the actual ones, if we already have the actual ones. And whenever it's not, we're going to fit some sort of curve. Okay. To do that curve, uh, let me actually cut, insert. I'm going to fit a curve I'm going to let Excel fit a curve where you have maturity in the x-axis and the log of the rate in the y-axis. The way you do that, you pick these, okay? Insert charts, and I'm gonna, doesn't matter what it is. Let's do this, okay? That's my log curve. Of course, I'm gonna end this. But I am going, and let me put this chart into a separate sheet so that I can see it bigger. All right. You can, I mean, this curve is drawn by Excel, but we don't know what the formula of that is. I can fit a curve to this, click on the series or the curve, right click and say add trend line. And I'm going to make it polynomial. You can have up to order 6. Man, that's too much. And let's also do 6. Let's see if you get it. No, 5 seems to be a much better fit. In practice, we have a lot more sophisticated methods, uh, but at this point, I don't know what that equation is either. So I'm going to say display the equation on the chart. Maybe let's do this. This may be a better one. Okay. I can actually Oh, let me delete it and do it from the start, insert, something like that. And trend line, polynomial. Let me see what it's going to do if I do 6. Yeah, 5 seems to be better. Okay, and okay. Normally, I don't care too much, but I cannot control the precision of the numbers that are displayed. Let's go to, oh, move the charts. You can move this thing around. Come on. So we're going to get the coefficients. Come on, from there. 0.6202. Coefficient of x negative 0.0048. Coefficient of x squared is positive 2067. Coefficient of x cubed is negative 4828. Positive 4806. And negative 0.1586. So when I'm fitting, I'm going to take the log of the maturity as my x, and I'm going to calculate that polynomial, even though this is, in fact, let's call this because I don't need these things to be that big. I'm just trying to maximize my screen space. Otherwise, it doesn't matter. Now, these rates are, let's see, I'm going to look it up in this one, but I'll get the fourth column. Anywhere where it's not NA, it's the actual rate that we observe. In terms of fitted, I'm going to say first I'm going to write the fitted directly. Degree 0 plus degree 1 coefficient times my log of maturity This is a highly inefficient way of calculating a polynomial, but I'm not going to worry about it.